9.5 day 1, we're going to graph tangent and cotangent graphs. So for the first one, we're going to graph the parent function for tangent x. So f of x equals tangent x. We're going ahead and use this circle. We're going to start with the corners because they're easiest, and then we'll see if that gets us anywhere. Okay, on the circle, what is this? This is 0, this is pi over 2, this is pi. Let's label these points because they're the helpful ones to start with. Okay, I'm going to start just with these ones. Okay, tangent is y over x on the unit circle. So I'm going to do y divided by x. So if I start at tangent of 0, 0 divided by 1, 0. Okay, let's go to pi over 2. If I go to pi over 2, y divided by x, undefined. If it's undefined, that means on the graph there's going to be a vertical asymptote there. So at x equals pi over 2, I'm going to go ahead and create an asymptote. Okay, now I have an asymptote here and I have a point here, so even though it's weird, I'm going to actually go backwards and figure out what's happening to the left of the 0, 0 point. So I'm going to go back to negative pi over 2. To get to negative pi over 2, I'm going to go backwards this way. So I'm going to call this negative pi over 2, even though that is the same as 3 pi over 2. Okay, at that point, the ordered pair is 0, negative 1. Okay, so if I do the tangent at 0, negative 1, it's y divided by x, negative 1 divided by 0. That's undefined again. So at negative pi over 2, there's another vertical asymptote. Okay, so I know there's going to be something happening in between here, but I don't know if it's going like this, if it's going like this. I have no idea what's happening, so I need another point. So the corners are not enough here. So I'm going to go ahead and go between 0 and pi over 2. Between 0 and pi over 2, I'm going to go to pi over 4. Okay, the ordered pair at pi over 4 is root 2 over 2, root 2 over 2. Okay, tangent is y over x. If I do root 2 over 2 divided by root 2 over 2, I get 1. So the ordered pair at pi over 4 is 1. Okay, that's helping because I know it's going to go towards the asymptote. It's going to go here. Now, is it going to go back up or is it going to go down? To figure that out, I need to go figure out some point in here. If this is 0 and this is negative pi over 2, I want to pick a point in between the two. So I'm going to go to here, which is negative pi over 4. It's also 7 pi over 4, but for my graph, it's easier for me to call it negative pi over 4. The ordered pair there is root 2 over 2, negative root 2 over 2. If I do y divided by x, negative root 2 over 2 divided by positive root 2 over 2, they cancel and I get negative 1. So at negative pi over 4, I'm going to have negative 1. And I'm going to use the asymptotes to figure out the shape of the graph because the graph should be approaching the asymptotes. Okay, so on near the pi over 2, the graph goes up. On the left side, it goes down towards the other asymptote. Now this graph actually repeats again, so if I kept going, it would do the same thing again, but I'm only going to graph one cycle here. So I'm going to write down some important information about the graph. There's an intercept at 0, 0. There's a vertical asymptote at x equals pi over 2 and x equals negative pi over 2. Okay, and then the ordered pairs I used in addition to the 0, 0 was this point and this point. So the tangent of pi over 4 was 1. So at pi over 4, 1. And then I went to negative pi over 4, and I got negative 1. Okay. Because all of this took place from negative pi over 2 to pi over 2, which is from here to here, it completed the full cycle in half a circle, which means the period is only pi. Okay, this is the parent function. Most of the graphs are based off this function. So using this function, we're going to try to figure out the graph of 2 tangent x. Okay, the only thing different on this is the 2. There's not really an amplitude, but there is a vertical stretch. So we're going to do a vertical stretch of 2. The intercept was 0, 0. If I multiply by 2, the y by 2, it stays at 0, 0, so that's not going to change. Okay, there's a vertical asymptote at x equals pi over 2 and negative pi over 2. A vertical stretch will not affect the x's, so the asymptotes will still be at x equals pi over 2 and x equals negative pi over 2. There is no scale here, so I can space it out however I would like to. I know I am going to put a point in the middle, so I'm probably going to do an even number. I'm just going to go ahead and make this pi over 2. You must label it so I know your scale. Okay, so at positive pi over 2, there's an asymptote. And then at negative pi over 2, there's an asymptote. Okay, now the points. My points over here were pi over 4 up 1, but there's a vertical stretch. So at pi over 4, it's going to go up 2. My other point was negative pi over 4. So at negative pi over 4, it went negative 1, but instead of going negative 1, it's going to go down 2 because there's a vertical stretch. Okay, and even though it looks weird, the asymptotes are guiding the graph, so on the right side it's going up, on the left side it's going down, and it does kind of look like a weird slide or a waterfall. Okay, the period is still pi because the x was not changed in any way, and it completes its full graph between negative pi over 2 and pi over 2. Okay, one more tangent graph. Okay, on this tangent graph, it's tangent of 3x. Okay, if we're doing a 3x, we're affecting the x's. So it's not affecting the y's, it's only affecting the x's. Now the intercept is still 0, 0, because the tangent of 0 is 0. Okay, now normally there is a vertical asymptote. Where is it? It's right here and right here. Okay, normally that is at pi over 2. But I'm going to divide by 3 to change it to where I want it to be. So it's going to be pi over 2 divided by 3. If I do pi over 2 divided by 3, I get pi over 6. I'm not going to change how I graph it, but this mark right here, I'm going to call that pi over 6. Okay, there's also one at the negative pi over 2, but if I divide by 3, it'll be at negative pi over 6. Let me label that negative pi over 6. Okay, now my points are normally pi over 4 and 1. The y will not change, but the x value will change. So instead of it being at pi over 4, I need to divide by 3. If I do pi over 4 divided by 3, I get pi over 12, but it still goes up to 1. So where I place it on the graph doesn't really change. It's going to be right here. That is between 0 and pi over 6. At negative pi over 12, the graph's going to go to negative 1, which is here. I'm going to go ahead and draw my graph in, which looks very much like the parent function, except for because of the change in period, the x labels got changed. Oh, the period. Okay, the period is normally pi, but because of the 3x, I need to divide by 3. So now the period is pi over 3. Okay, that's the graph of tangent. Right now we're going to graph cotangent. Cotangent is a similar graph, but it's a little bit different. I'm still going to use, so I'm going to start off using the corners, and then I'll add in more points as I need. Okay, 1, 0, 0, 1, negative 1, 0. If we're doing cotangent, that's a reciprocal of tangent. So instead of y over x, I'm going to do x divided by y. If I do x divided by y here, that's undefined. Okay, so at 0, there's actually a vertical asymptote. Let me write that in. Okay, let's go to pi over 2. If I go to pi over 2 and I do x divided by y, I do 0 divided by 1. So at pi over 2, I'm going to hit the 0, which means actually there's an intercept at 0. Let me change this to pi over 2, comma 0. There's no y-intercept actually. Let's go to pi then. Okay, if I go to pi, if I do x divided by y, I get undefined again. So now there's another asymptote at pi. Okay, now I know it's going to be similar to the tangent graph, but it's not quite the same because it looks a little different. I'm still going to use pi over 4 to figure out the missing tangent value. Okay, the order pair here is root 2 over 2, comma root 2 over 2. It has a nice tangent value, that's why we use it. Tangent was y divided by x. Cotangent is x divided by y. If I do root 2 over 2 divided by root 2 over 2, I still get 1. So at pi over 4, it's still 1. So the pi over 4 1 point does not change. Just the asymptotes and the zeros changed. Okay, I need one other point. I know something's going to happen between here and here. I know it's up here, hits 0. I'm guessing it's going to go down here because that seems reasonable, but let me double check. If I go between pi over 2 and pi, over here in quadrant 2, I'm going to go to 3 pi over 4. Since this is in quadrant 2, the x is negative, the y is positive. Okay, if I do cotangent here, I do x divided by y, so I'm going to get -1, which is what I thought. Okay, so the parent function here is higher on the left side, and then it goes down on the right side. So it's similar, but it's not quite the same. The period is still pi. It's easier to actually tell the period here because it starts at 0 and it goes till pi. It would repeat forever because it is a periodic function. Let's do 2 more cotangents. Okay, cotangent, what are we doing? 1/2 cotangent x. The 1/2 is a vertical shrink. It's only going to affect the y values. It's not going to affect the x values. So the intercept, no, let's do the asymptotes. I forgot to label my other asymptote. Okay, the asymptotes are still going to be at x equals 0 and x equals pi. So I'm going to keep them there. Asymptote. Okay, I'm going to figure out 1, 2, 3 points in the middle. So let me leave 1, 2, 3 points in the middle, and I'm going to put pi way out here. 1, 2, 3, 2. I'm going to label it pi, so I have a scale though. Okay, what was my intercept? My intercept is pi over 2, because the cotangent of pi over 2 is 0. Okay, if I go to pi over 4, the tangent was 1, the cotangent is also 1. So that tells me it's going to go up on the left, which means it's going to go down on the right, which tells me at 3 pi over 4, it's going to go to -1. Oh shoot, there's a vertical shrink. Hold on, 1/2, 1/2. And let me erase my dot. So now I'm only go halfway, halfway. Still goes up on the left, down on the right. And I'm going to go ahead and sketch it, approach my asymptotes, and then figure out what I wasn't paying attention to left off. Okay, there we go. That's my 1/2 cotangent x, vertical shrink. The period is still pi because it takes from 0 to pi to do this little down waterfall situation. Okay, let's do one more. This is the cotangent of 5x. So it's only affecting the period or it's affecting the x's. Okay, let me go ahead and do my asymptotes first because I think they're easier. Okay, x equals 0 is a vertical asymptote. Okay, and then I normally put the vertical asymptote here. That's normally at x equals pi. But because it's 5x, I need to divide by 5. So this is now going to be pi over 5. As long as you label a point on your scale is now correct. So I'm going to now graph this according to the scale. Okay, the intercept is normally at pi over 2, but since I'm dividing by 5, it's now going to be at pi over 10, comma 0. It's also going to be right in the middle here. Because it's cotangent, it's going to go up on the left, but I mostly just remember the pi over 4. Okay, normally at pi over 4, it's 1, but this is divided by 5, so it's going to, instead of being divided by 4, it's going to be divided by 20. Okay, since I know this one is up, then I know the one on the left is down. That's normally at 3 pi over 4, but I need to divide by 5, so now it's 3 pi over 20. Okay, and then I'm going to approach my asymptotes and sketch my graph. The period is normally pi, but because it was 5x, it got divided by 5. So now the period's pi over 5. So from 0 to pi over 5, it does one cycle of cotangent.